Okay, guys, so can I start now? Okay, so good afternoon, everybody. So what I did, what I taught before. Okay, let me go here. So I taught these LEDs before. Okay, I taught these LEDs as I told you before. It's connected to port B, as you see here. It's connected to port B. I told you I'm going to use BG1 for enable or disable. That's what I told you. That means if you put here 1, that means all of them are disabled. Okay, which means if you put here 0 or 5 volt, 1 means 5 volt, nothing is going to happen. Okay, because it is disabled. However, as I mentioned before, if you put here 0, so you enable. What enable means, if I put here on this pin, if I put 0, it's off. If I put here 1, logic 1, which is 5 volt, it should be on. Okay, that's what we did before. Okay, now I want to talk about 7 segment. Believe me, there is no difference. The only difference between this structure and the 7 segment, the only difference is this one. Instead of using BG1, because we have 4 7 segment, so here the enable we are going to use PB0, PB1, PB2, PB3. That's it. Everything else is the same. So they are connected to port B. That's number 1. Number 2, the 7th segment, every segment is 1 LED. You got what I'm saying? So if you look at the 7th segment, guys, we have segment this way. So we have 7, as you see here, 7 segment, and we have dot, 1 dot here. Okay, so every one of them is one LED. That's it. So this LED is this one is this one. So as a structure, it's almost the same structure like this one. The only difference is that's why programming will be exactly the same thing, right? If you want to turn one segment on, so you have to put here 1. If you want to turn this segment off, you have to put 0. Same thing. This enable here, this enable bit, it has to be 0 to enable this 7 segment. Is that okay? So I'm gonna elaborate more here. I like this topic. It's interesting. So as you see here, guys, as you see here, we have 4 7 segment. These 4 7 segment are connected to port B. Okay. Also, the cathode here is connected to PB0. This is for enable, as I told you. So 0 means enable, 1 means disable. As you see here, that's what I explained last time. Every segment is 1 LED. That's it. And every segment should have 1 pin. 1 pin. If you put 5 volt or 1 logic 1 on this pin, you turn this segment on. That is why if I want to display number 0, so all of them should be on, except G has to be off. Okay, to get number 0, to give the shape 0. To do that, as you see here, you have to put 1 1 1 1 0, and this should be 3F. So this is the number I have to put in port B in order to see 0. Okay, so every number should have a code. Okay, same thing if you want to do like number 5, you have to put 6D, because number 5 you are going to turn everything on except E and B and so on. So the conclusion is, if you have any problem to understand this one, let me know. So very simple. The conclusion is, if you want to use the 7 segment, all what you have to do is, number 1, similar to the LEDs, you have to enable the 7 segment. How? Similar to what you did to LEDs. The only difference is here we are going to use PP instead of using BG1. We're going to use PB0 or PB1, 2, or 3. Okay, every segment has 1. Anyway, this is number 1. Number 2, if you want to display any number here, so you have to take the code or this code and put it in port B. That's it. You got it? Any question? Very easy, right? So, by the way, sometimes, you know, these 7 segment, usually they are used for numbers, usually. However, they can write some letters, but very few letters. For example, like letter L, right? Sometimes they can do H, So in this case, you need a different code. Okay, so this code only for digit. Okay, for example, you can do something low or high, HI, for example. Anyway, very few letters, but usually they used for numbers. Anyway, so all what I want to say, if you want to use this way, it's totally fine. The only difference is you have to, using the same idea, you have to use a different code. That's it. Okay. Anyway, so now I want to start with the first program here. The first program, I call it counting 7 segment. Okay. So you have a 7 segment, it should count. So 0, and then it's gonna wait 1 second, 2, 3, 4 until 9. After 9, it should come back to 0. I want to do this program. Okay. No interrupts here. So I want to do it in the main program. Okay. So before I do that, I'm going to choose a video first to understand exactly what I want to do. After I choose a video, I'm going to explain how it works. Yeah, counting 7 segment, okay? Okay, guys, as you see, 1, 2, 3, maybe the camera is not very good, but there are, you can see 6, 7, 8, 9. After 9, it's going to go back to 0. Okay, so here I'm using only one display. Here I make the delay 1 second. For sure, as you know, as we did before, you can make it longer or you can make it shorter. If you want to count faster, you can make it half a second and so on. Okay, so how can we do this? That's what I'm in both in C and assembly. That's what I'm explaining here. Okay. So as you see here, number 1, you have to configure, because I'm using port B, so you have to configure port B output. That's very easy, right? Also, because I'm using port P, so you have to configure port P output, especially the first 4. The first, here I'm using only, there is something here very confusing, especially for the coming tests. Okay, what is this? Okay, here the problem is that if you look at port P, the first 4, starting from PP0 to PP3, the first 4 are used to enable segments. Is that okay? And then from 0, 0, 1, 2, 3. Okay, this is 4. And then 4, 5, 6. Is that right? These ones are used for RGB. Is that okay? Here, in this program, I'm not going to use the RGB. So I don't care about what value I put here. So it's not going to make a difference. I don't care because I'm not using, I don't care about the RGB. Okay. However, in case in the test, because you are using both of them, the RGB and also the 7 segment, so you should care. Okay. I'm going to tell you which part can make trouble here. Okay. For example, here, look what I did here, guys. So here I configure port B as output, but here I put 0F because I just care about the first 4 bits. I don't care about the other bits, right? Because I'm not going to use them. However, in the test, this should be F, right? Because you are going to use all
Dr. Mahmoud, I had a question.
So this is one thing. The other thing is, look what I did here, guys. Here, I wanna enable display 0. Okay, so if you wanna enable display 0, all what you have to do, I have to do here, I'm gonna put here 0, and there should be 1, 1, 1. Is that right? Because these are the 4 displays. Is that okay? What about what you have to do here? Okay, in this program, I don't care. Why? Because I'm not using RGB. So if you put zeros, okay, someone. Yeah, so for the test in the coming lab on Thursday, you are gonna do demo for the test. Okay, if everything works well, you are gonna get the full mark, and that's it. If it doesn't work, so I'm gonna ask you to send us the program or print the program, and then we are gonna grade the program. So it is like, it's like a lab, for example, but like, and we can help you, but you have to finish in the 3 hours, and you have to do your best to finish it before you come, because the weight of this test for sure it's much more than any lab, because it's going to be around 7%. Okay, so you have to do it before you come. Anyway, so what I'm saying here, guys, I don't care whatever you put here. That's why I'm just using move here. Okay. This is if you do the same thing, this is gonna create a problem in the test. Okay. Why? Because I'm using RGB. So what can I do now? I'm gonna tell you. Please try. You have to be very wise when you use move. Okay. Instead, because move is gonna change everything. Okay, all the bits. Instead, try to focus only on the bits you want to change. For example, here in this one, so I wanna here, I wanna put here 0, 1, 1, 1, and here no change. I don't want to change this part. Are you okay with that? So how I can do this? How I can do this way? You have to use bit set to change these 3, one instruction, and then you have to use here bit clear to change this one, to do this one. Is it, you understand what I'm saying? Instead of using move. Okay. Anyway, here in this one. And then after that, so here I enabled one 7 segment, I disabled the other 7 segment by putting here 0, 1, 1, 1. Is that okay? So, and then here I also, because I'm not using the LEDs, okay? However, I have to disable the LEDs. Otherwise, if you don't disable the LEDs, or what's gonna happen is that whatever you write on port B is gonna appear on the 7 segment you enable. So if I enable more than one more than one 7 segment, for example, if I put in port B the code for number 3, this is port B. If you enable more than one 7 segment, you are going to see 3, 3, 3, and so on. If you enable more than one, okay, which doesn't make sense anyway. So I'm going to, as I'm going to explain later, only one of them should be enabled at a time. So that's why here I have to configure port G output BG1, okay, and also here I have to set BG1. If you remember what we did before, we cleared BG1. So here you have to set. Why you have to set BG1? Because I want to disable LEDs. Is that okay? Very easy. So this is just the configuration. I did just configuration at the beginning here. Okay. And then now the program is going to be here. I'm going to have a loop. We're going to loop this way all the time, from here all the time this way. So I'm going to explain the idea, how it works. The idea is very simple. Before I explain here, the idea is very simple. So here, this is the table I should have. This is the code for the numbers. Yeah, these numbers here. I put them in a table, as you see here. And the idea is, in the very beginning, X is here. Very beginning, X is pointing here, okay? And then I'm gonna take the value pointed by X, I'm gonna put it in port B, okay? So I'm gonna take the value pointed by X, I'm gonna put it on port B. And then I'm gonna increment X to point here. This is one iteration. In iteration number 2, I'm gonna repeat the same thing again. I'm gonna take the value pointed by X, I'm gonna send it to port B, okay? And then I have to increment X. I have to keep doing this. And also, in every iteration, I'm gonna wait 1 second, okay? Because I wanna wait 1 second until X comes here. So, or once X comes here, so I have to return it back to here. So once I finish this one and I increment X, it should be here. So I have to reset it back to here. Yeah. So that after number 9, I have to get number 0. Okay. So this is the main idea. Very simple. So let's see how I made it here using the code. So as you see here, guys, load X with display. Okay. So X is gonna, I initialize X. So X is pointing at the first number, as you see here. This number 1. Number 2, I'm gonna get the byte. I'm gonna get a byte pointed by X. I'm gonna write to port B. I'm gonna read the byte pointed by X. I'm gonna put it in port B. Then I'm gonna increment X for next time, for next iteration. Then I'm gonna wait 1 second. Okay. Then now I check. I need to check if X came here or not. So I'm gonna check if X equal to display plus 10. So this is the display. This is the address of the first one. Here should be plus 9. Here should be plus 10. Okay. So if X comes to here, I have to bring it back to here. Okay. So that's exactly what I did. So here I'm gonna check. If not, if it is not equal, so I'm gonna come to here. So let me clear this one. So what I'm saying, if it is not equal, so I'm gonna come to here. To do what? To I'm gonna take a byte pointed by X, increment X, okay? If you didn't reach to the end yet, just come to here. So I have to do this part 10 times. So it's gonna be 10 times for the number from 0 to 9. Is that okay? And then if it is equal, so once I come to the end, I'm gonna come to here. And this one is gonna send to me to this one to reinitialize X again. So once X come to the end here, I'm gonna reinitialize it to here. Any questions? Any question, guys? Is that clear? Okay. So now what I'm gonna do right now, there is a big difference here, guys. Listen to me, because this is a big difference between, there is a big difference between LCD and 7 segment. Okay, guys, big difference. In case of LCD, you just write, once I write the number or the letter one time, that's it, right? Here, no, okay? Here, I'm sorry, yeah, this is for more than one segment. So I'm gonna explain it later in more than one segment, I'm sorry. So that's okay. So here's the same thing. Once I write it one time, it should be okay. Once you write it one time, it should be okay. However, when you use more than 1 7 segment, you have to keep rewrite it, as I'm gonna explain later. So it's not related to this one, related to what I'm gonna explain later. So now I'm gonna explain how can you do the same thing in C language. I'm gonna explain two ways to do it, okay? So the first way I'm gonna do it, I'm gonna do almost the same idea like this one. I'm gonna create array. This array has these values, and then I'm gonna use this. So the idea is gonna be too close to this one. So let's see how can you do the same thing in C language. As you see here, guys, number one, I created array. This array has the values here, okay? So this is for number 0, for number 1, and so on, okay? And then here you have to, we have here a function. You know, in C language, you can use assembly, so you can manipulate or you can write to register like assembly format, or you can use functions, okay? So here I used this function. I said LED disable, okay? So we have a function. This function is gonna disable LEDs. And this one is going to enable 7 segment, okay? So I'm going to explain, and then later you can select which 7 segment you wanna enable, as you will see right now. Look here, guys. And then now I'm going to have for loop, as you see here. I'm going to have for loop. This for loop I have is going to go through from 0 to 9. So here I should equal to 0 in one iteration. I equal to 1 until it is 9 here. Is that okay? Let's see what should happen in every iteration. In every iteration, I'm going to use this function. Okay, so let me clear it here. I'm going to use this function. What this function is doing, I'm going to tell you what this function is doing. Whatever you put here is going to put it in port B. And then here you select which display you want to enable. Okay, so if I put here 0, that means I want to enable display 0. If I put here 1, it means I wanna enable or I wanna write this value to display number 1. So here you should put a value from 0 to 3, okay, to tell which display. So here I'm gonna use display number 0. That's why I'm not gonna change it. I'm gonna fix it 0 all the time, okay. And then as you see here, guys, in the first iteration, I is equal to 0. So I'm gonna take this value from the array, digits 0, which is this value. I'm gonna send it here. And what this function is doing, whatever you put here is going to put it in port B, right? So this one, so what this function is doing, port B should equal this value. Is that okay? So this idea is somehow very close to assembly. You have to create a table or an array, and then you have to take one by one and put it in port B. Okay, so this is one idea. There is another idea, higher level. So I'm gonna hide the details, higher level. Again, whatever you like, it's okay. But I have to explain it in different ways, right? So there is another idea, which is this program. You can see this program is much shorter. Look, it's very shorter comparing to this one. Why? Because details are hidden in functions, and this is the main purpose of using C. I'm gonna put all the details in a function. And you can just use the function, okay? That's what I did. So now I don't need to create a table like this one. You don't, okay? Because it's already inside the function. All what you have to do, you have to use a different function. And instead of using this one, we're going to use a different function. This function is called segment 7 decimal, okay? all what you have to do here, just to give me the number. And then this function is going to convert the number to the code and put it in port B. That's it. So for example, if I say here number 7, so this function is going to convert the 7 to the code, put it in port B. You got what I'm saying? Or you can say here number 9 and so on. Here also the second argument here, you can select the display, which display. Okay. So again, if you like this one, yeah, use it. It's okay. Okay. However, okay, I'm going to tell you what I want to say here. Using functions is going to make everything easy because details are hidden. You just use it. Okay. However, the problem here, what if you want to modify something? It may be difficult to do that because the function is designed to do something. Okay. Maybe difficult. For example, if I want to instead, so this one can only be used if you want to display number from 0 to 9. That's okay. However, as I told you, if I want to display letter L on the 7th segment or H and so on, okay, how I can do that? For sure, you can't do this here. You have to do it here. So in this case, you have to use this one here. Okay. So that's why I'm explaining the same thing maybe in 2 different ways. Okay. So for example, you can put here the code you want to put and just use it. Okay. Anyway, so here this is just a very simple function. This function is used if you want to display numbers. Just to put the number here from 0 to 9. Just to put the number. You don't need to worry about the conversion of this number to the code, 7-segment code. And thus, just tell me which display. That's it. Okay. So that's why you see here, guys, what I'm going to do here, as you see here in the first iteration, I is equal to 0. Okay. So I'm going to display number 0 in display 0. I'm going to display number 0 in display 0. And then I'm going to wait 500 milliseconds, half a second. Then I'm going to go back. Next time, I is equal to 1. So I'm going to display number 1 on display 0. That's it. All the way until I is equal to 9. So I'm going to display number 9 on display 0. And then because I have here infinite loop, I'm going to repeat again from 0 to 9. Okay. Any questions? Any questions? Very simple, right? Any questions? Okay. So just a very simple function. Now, let me see here. Yeah. Okay. Look here, guys. I want to tell you, and I mentioned it before. If you have a task, you can put this task in the main program, or you can put it in interrupt. It's up to you. You understand what I'm saying? So, for example, if you have application and this application you have 3-4 tasks, you need to decide this task is going to go to the main program. This task is going to go to interrupt 1, interrupt 2, or whatever. Is that okay? So now I want to show you it in one program. So I'm going to repeat what I explained right now in the counting 7 segment. I'm going to repeat it again, but what I did in chapter 3, so it's exactly the same program. The only difference is this program I have taught right now. So the only difference is this program I put it in the main program, right? Now I'm going to put it in RTI. So I'm going to count, and this counting should be done by RTI. So now the main program is free. You can put anything else if you want to do something else, you can put it in the main program. Is that clear, guys? So I'm going to repeat it here maybe 2-3 times. In 2-3 programs. In chapter 3, I'm going to put them in the main program. In chapter 4, I'm going to show how can you put them using RTI. Okay, you should understand, as I mentioned, some tasks you can put it in different places, and you need, for sure, this is something you need to decide where you put it. So now I'm going to explain the same program. However, I'm going to use here RTI to do it. Okay, it's the same program. When you count 0, 1, 2, 3, it's the same program. Okay, so how can you do it? I'm going to tell you how. Very simple. So the idea I have to do it is you have RTI, right? So RTI can trigger interrupts every 1 second. I told you before we can have 8 interrupts as we did last time. 8 interrupts. That's okay. I ignore the details. At least now I can have interrupt every 1 second. Is that okay? So all what I can do here, guys, is In the first interrupt, I'm going to display this one. In interrupt 1. Then I'm going to wait 1 second. In interrupt 2, I'm going to go for this one. Interrupt 3, interrupt 4, 5, 6, 7, all the way until here. Once I'm done with this one, I have to come back here. So every interrupt, I have to display one number. And next interrupt is after 1 second. You got what I'm saying? I want to tell you also something very important. Listen to me. Someone can ask me, okay, so you want to use RTI to do this problem? Why you didn't use IRQ? Okay, man, here IRQ is not going to help me, right? Here I need periodic action, periodic, right? It's like here every second, I want to do something every second. That's why this should be done by using RTI, and it cannot be done by IRQ. IRQ, it is only when you have event, or you push whatever the event you define it. Every time you have event, you need to trigger interrupt. So this is completely different. If you want to do like periodic operations, you have to do it using RTI. Is that okay, guys? Any questions? Okay, any questions? Okay, so now the idea is very clear. The idea is that I'm going to have interrupt every 1 second, right? In every interrupt, I'm going to get the location. In one interrupt, I'm going to get this one, then this one, this one, this one, this one, all the way until here. Okay, guys, any questions? Okay, look here. This is very serious. Okay, look here. So the way I did it in chapter 3 is I used register X, as you see here. So register X was here. Every iteration, I increment X, increment X, increment X. Is that okay? Can I do the same thing in RTI? Every interrupt, I'm going to increment X. In every interrupt, I'm going to, why? Why no? That's true. This is because what happens in interrupts is automatically X is going to take the initial value back automatically. Is that okay? So you cannot do it. You cannot do it using. You cannot. It doesn't memorize the value of X. It has to be a memory location, and that's what I'm going to do right now. Okay. So the way I'm going to do it, guys, is as you're going to see right now, is I'm going to define. Oops. So number 1, I'm going to define a variable. This variable is called RTI count. Okay, and we used it before. This one should be RTI count. This one to count the number of interrupts. Okay, because I have to display every 8 interrupts. This number 1. So number 1, I need a counter to count interrupt 1, interrupt 2. Every 8 interrupts, I have to make something. Okay, every 8. So I need to count interrupts. That's why I have to this one similar to what we did before. Okay, guys. On top of that, I'm going to use another memory location. I'm going to call it count. Is that okay? In interrupt 1, count is 0. Is 0. Okay? So if I add the initial value, I can put the initial value in X. So always X is pointing at the first location. X plus count is going to be here. Is that okay? Then in next interrupt, I'm going to increment count. So count now is 1. X, I'm not going to change X. X always is equal to the first location. Okay? So what's going to happen? X is going to be the first location. In the first interrupt, it's going to be X plus count. That's how it is. This should be give me the address. Okay? So count here in the first, after every 1 second, it is 0. After another second, it's 1. Another second, it is 2, and so on. You got what I'm saying? So X, I'm going to fix X, and then I'm going to add 0. I'm going to add 1. I'm going to add 2. I'm going to add 3, and so on. Once I come to here, I finish this one. I have to come back to here. Is that okay? So very serious. You should understand why I used a memory location. Why, if you compare the same program I taught in chapter 3 and chapter 4, you should understand why it was okay to use X in chapter 3, but here you need to use, in addition to X. In chapter 3, I changed it X. X is pointing on the number, but here X is going to point always at the first location. But I need to use a memory location to remember this is number 0, number 1, number 2, and so on. So now I want to choose a program here. Any questions? Okay, so I'm gonna choose a program here, guys. Number one. Okay, so here this is the initialization for RTI. So you need to initialize RTI. Same thing here in the main program. I have to initialize 7 segment and LEDs. Okay, as we do before, nothing here is new. Then similar to what we did before, I'm gonna put here number 7F to make it every 131 millisecond. Make interrupts every 130 as we did before. Okay, and then that's it. So the main program is free. I'm just looping because this is just a simple program, right? So it's free. Anyway, you can put something here. Anyway, so now let's look at so who's gonna drive, or who's gonna run the 7 segment RTI. So this task is completely done by RTI. 0, 1, counting 0, 1, 2, 3, 4, 5, 6, and so on by RTI. So if you want to stop counting at any time, just disable RTI, okay, and so on. So anyway, let's see how it works here. So again, as I mentioned before, you have always to write this one. You have to clear the flag bit. Don't think if you forget this one, you will regret. Okay, so your program is gonna stuck here. It's not gonna work. So don't forget it. Okay. Also, and you have to end it with RTI. So these two we don't need to think about them. Okay. Number 2, I have to count interrupt 1, interrupt 2. So if in case of interrupt 1 to 7, I'm not gonna do anything. Just leave. It's similar to what you did before, because I want to change the number every 8 interrupts. Okay, every 1 second. So that's what I did here. Look here, guys. I increment RTI count, and I'm gonna compare it to 8, and then if it is not equal to 8, so I'm done. Come here and leave. I am done. So I'm not gonna execute this part. So this part is gonna be executed every 8 interrupts. In other words, every 1 second. Is that okay? Very simple. This is because every 1 second. Okay. So here I'm gonna count if it is this interrupt is less than 8, come here. So okay. So now every 8 interrupts, I'm gonna come here. Okay. So what you are gonna do here? I'm gonna tell you what I'm gonna do. Okay. As you see here, guys. So every 8 interrupts, I'm gonna come here. I'm gonna execute this part. Okay, every 8 interrupts. See what I did here. Number 1, you have to clear the count, RTI count. So I have to clear it. Why? To count for another 8. So every 8, I'm gonna clear it to count another 8. This is number 1. Okay. Number 2, I'm gonna display. How can you display? As I told you, very simple. X should point here. Then I'm gonna take the location X plus count. I'm gonna take this one, X plus count, whatever the location pointed by X plus count, I'm gonna put it on port B. Also, you need to increment count, and you make sure if count to come here, bring it back to here. Is that okay? So the question is, how can you read the byte pointed by the location X plus count? How can you do that? The very simple way to do it, as we did before, is we have this format, guys, A comma X, right? You remember this one? A comma X. A comma X means the location pointed by X plus A. But before you use it, you have to put count in A. Is that okay? Very simple. That's what I did. So if you see here what I did, X, I'm gonna initialize the X with the first location, as you see here. Then I'm gonna put count in A. And then I'm gonna take the location pointed by A comma X, I'm gonna put it in port B. Is that okay? And then after that, now I'm done. I'm done. All what I'm gonna do after that, I have to increment the count. I'm gonna increment the count. Then I'm gonna make sure if count is 10. Okay. So I'm gonna increment the count. I'm gonna compare it to 10. If it is not 10, just come here. If it is 10, so come here and to clear count. So I'm gonna clear it every 10. Okay. Why 10? I'm gonna tell you why. Because in the very beginning, count is 0. Here, count is 9, not 10. Okay, but remember, every time I display 1 digit, I increment the count. You got what I'm saying? So here, after I display 9, Here I display 9. So here, when I come here, I increment the count. So once count is 10, it means I already displayed number 9. Okay, so I have to come back to here. Any question, guys? I love teaching these two programs this way. You can see the main program. It's the same thing. I put it in the main program. It's the same thing how I can put it in RTI, right? You need to learn that it's the same thing. I can do it by putting it in different places like RTI or the main program, but you have to consider the differences. As I told you, like register X, you cannot just simply increment X, okay, and use X for next time. You cannot do that, okay? Any questions? Should I explain it again? Okay, guys. So every 8 interrupts, I'm gonna come here. Number 1, as you see here, X, I'm gonna initialize X. Number 2, count is gonna go to A. Then A comma X, you remember A comma X, this one. So I'm gonna get the location pointed by X plus A, and A has count. Okay, so I'm gonna get the location pointed by X plus count. Okay, then I'm gonna increment the count, and if count is not 10, do nothing. If it is 10, you have to clear it, so that after 9, you are gonna go to 0. Any questions? Okay, now I'm gonna go back to chapter 3 again. So here I want to explain. So I already explained here, number 1, how the 7 segment is connected. How can you use the 7 segment? Okay, but what I explain right now is how can you use a single 7 segment, 1. Okay, what if usually or in many cases you may have more than 1 7 segment? Okay, how can you do it if you have more than 1 7 segment? For example, in my application, I want to use, for example, 3 7 segment. How can you do it? I'm gonna tell you the bad way or the naive way. Usually we don't do this way, okay? And then I'm gonna tell you the correct way, okay? Or usually how we do it, okay? So if you have 3 7 segments this way, that means I need 3 ports. So this one has to be connected to 1 port. This one has to connect to 1 port, and this one has to be connected to 1 port. And then you can put here the code for number 3 so that you can see 3. And then here you can put the code for number 5 so that you can see 5. Here you can put the code for number 7 so that you can see 7. This is how it is, okay? So you can convert the 3, or the 3 is going to be like the single. It's like one single. So you can use the same program I have just taught right now. You can use it to display them this way, okay? So why you are saying this a bad way? The reason I'm saying, for sure, it's okay, it works, but we usually wouldn't do this way. Why you are saying this a bad way? The reason it is bad way because usually we don't have too many ports, okay? Especially if you have big application. You got what I'm saying? We don't have too many ports to waste 3 or 4 ports just for 3 or 4 7 segments. You got what I'm saying? So interestingly, what I'm gonna do right now is I'm gonna use a technique, we call it time multiplexing technique. Using this technique, I'm gonna use only 1 port. Okay? So that's what I'm gonna explain right now, okay? So the idea of the time multiplexing is like exactly, we have here port, we have port B. Okay, so in this port B, I connect all the 7 segments, 4 of them. Okay, and this is exactly our situation. This is exactly how the board is connected. So the 4 7 segments are connected to only 1 port. Is that okay? And everyone has enabled. So PB0, PB1, PB2, PB3. Okay, so if you put here the code of number 7, for example, if here I put the code for number 7, and all of them are enabled, you are going to see 7, 7, 7, 7. For sure, that doesn't make sense, right? So I don't want to repeat the number, right? That's why we don't use it this way. So again, the technique is called time multiplexing. And you will understand from the English word why it's called time multiplexing, simply because we do time multiplexing, as you will see right now. Okay. So the idea is I'm gonna enable only one display at a time. Let's agree on this. Okay, at a certain time you only enable one. Okay, and the idea is, for example, if I want to display number 3721, if I want to display a number like this one, guys. So the way I'm gonna do it here, I explained it in the lab quickly, but now I want to explain it in details. For example, here, this is port B, okay? So on port B, I'm gonna put the code for 3, okay? But I'm gonna only enable the first ones. That's why you can see here 3, and these ones are off. Is that okay? Let me, okay? So here I'm gonna put the code for 3, but only the first one is on, the other ones are off, okay? Now, I wanna display 7. So after some delay, okay, I'm gonna wait some time. And then here, this one is off. I'm gonna put 7 here, and the other ones are off. So port B should have 7. Is that okay? Then after a small delay, I'm gonna put here number 2, and the other ones are off. Okay? And then after some time, I'm gonna put here number 1, and the other ones are off. Is that okay? And then go back and repeat again. Okay, guys? So let's agree on this. At a certain time, only one of them is on. Let's agree on this. And a certain time, you just display 3 or 7 or 2 or 1. However, the trick is, if you can do that fast enough, as you will see in the video right now, you will see a very stable number. You cannot believe that only one is on at a time. Very stable number, as you will see right now. Okay. But the risk, or the point is that, what is the number one? Why you need a delay here? That's a question. Why you need a delay? Okay. We need a delay because microprocessor is very fast. If you just put a value and remove it quickly, if you put 5 volt, remove it quickly, what's going to happen is the 7 segments are going to become dim. Why? You have to keep the voltage, the 5 volt, you have to keep them for some time so that the LEDs can get the brightness. Okay, I told you before. So there is like, I can make something like that. This is the time, and this is the brightness of the LEDs. So you have to keep it for a certain time. Okay, 1 millisecond, 2 milliseconds. You can try and see. So what I'm telling you, if you after you write your program, if you find that the LED 7 segments are dim, that means you don't have, the delay is too short. You have to make the delay bigger. Okay, that's one thing. The other thing is, if I make this delay long, well, you are gonna see flicker. Okay, because there is a long time. So again, if you write your program and you see flicker, okay, just in case flicker, okay, if you see flicker, as you will see in the video right now, if you see flicker, that means the delay, you have to make the delay shorter. Is that okay, guys? You can try, put 5 milliseconds, put 3 milliseconds, put 10 milliseconds, and see what's gonna happen. Okay. So now, this is the main idea. We call it time multiplexing. Any question about it? Now you should understand what I mean by time multiplexing, why we need it, why it's interesting. What I'm gonna explain right now, how can we program it? Okay. I'm gonna teach it two times. One time, how I can program it in the main program, how I can do it in the main program. This number one. Number two, I'm gonna explain how I can do it using RTI. It's the same task, I can do it using RTI. Any questions? Okay, guys. Okay. Before I teach it, I want to show you the video here. I want you to see the flicker. Where it is. Yeah, this one. Okay. So here, yeah, you can see here, maybe the camera is not that good, but you can see the number is very stable. Okay, so let me see. I don't remember how much delay I made here. Let me stop it. Can I see? It's hard to see here. I think 1 millisecond, I guess, or so. Anyway, you can try it and see by yourself. So here, anyway, this one is stable. Now I'm going to change the delay. It was 5 milliseconds. Now I'm going to change the delay because I want you to see the flicker. Okay. I'm going to try, for example, I did here 100, for example, 100 millisecond. Okay. So I'm going to keep every number for 100 millisecond. And now you'll see how it has flicker. Okay. Now you can see it clear now, right? You can see the trick. You can see only one at a time. Anyway, so it's very simple, guys. So again, I'm going to repeat it again before I choose the program. Number one, if you run your program and you see that the numbers are dim, it means you need to increase the delay. If you see the numbers, there is a flicker, it means you need to reduce the delay. Okay. So now I'm going to explain the idea. How can you do it? Okay, I'm going to tell you how I can do it. Look here, guys. I want to display this number as you see here, number 3, 4, 5, 6. I want to display this number. Okay, so very simple. If you want to display this number, all what you have to do, if you want to display 3, so you have to put 4F on port B. If you want to display 4, so you have to put 66 on port B. If you want to display number 6, so you have to put 7F on port B and so on. Is that okay? So as you see here, so this is the number I have to put in port B. Okay. However, also you have to put some number on port P. Okay. Why you have to put some number on port P? Because when I display number 3, display 0, it has to be on. The other ones are off. You get what I'm saying? To do that, I put here E. That's why E. E means 0, 1, 1, 1. Is that okay? If you look here I'm going to put D, which is 1, 0, 1, 1. Here I put B, which is 1, 1, 0, 1. Here I put 7, which is 0, 1, 1, 1. So you can see here, I have to enable one display, and then I have to write this number to port B. Is that okay? Again, I want to tell you here in this program, I'm not using, please listen to me. In this program, I'm not using RGB. So I don't care about these 4 bits. I just put 0. I don't care about them. Right? However, the way if I use RGB, I'm not gonna, so the way I'm gonna do it right now, I'm gonna just take this number, I'm gonna write to port B. Just write number to port B. So I'm going to manipulate. I'm going to change these 4 bits. Okay, I don't care. I'm not using them. However, in the coming test, you are going to use them. So I don't want to, again, if there is a conflict, if you in the coming test, if there is a conflict between the RGB and the 7 segment, this is because of this problem. When you enable the 7 segment, you change the other ones here. So the way you should do it is, don't use move. Don't use move. The way you have to do it, guys, is number 1, you can say bit set, and then you put here like 0F. So you can set the first 4 bits. You can set all of them. That's okay. And then you can use bit clear to only one display you want, so you can change one display. For example, you can here put this one 0, or you put this one 0, only one. Okay, based on which one you wanna turn on right now. Okay, guys. So let me say it very simply. The way you are gonna do it, guys. Number 1. So here in the first iteration, I'm gonna turn. This is exactly what I explained right now. So I'm gonna turn this LED on. Then I'm gonna write this number here, which is number 3. Okay. Then in iteration number 2, I'm gonna turn this one on, and then I'm gonna write these values there. In iteration number 3, I'm gonna turn this one on, and then I'm gonna write this one values there, and so on. Okay. So now I'm gonna show how we can do the program. So very simple. Look at the way how I did it. As you see here, guys, I created an array. I just call it display tape or display table. As you see here, guys, here, this is the value you have to put it in port B, and this is the value you have to put it in port P. Is that okay? So if you see the way I did it, in the first iteration, I'm going to take these two values. In iteration 2, I'm going to take these two values. In iteration 3, I'm going to take these two values. In iteration 4, I'm going to take these two values, right? One to port B, and the other one should go to port P. Once I am done, I have to come back to repeat again here. Is that okay? So you have array. In this array, in every iteration, I'm going to take two values. One to port B, the other one is to port P. Once I'm done, I'm going to go to the beginning again. So how can you do it? Very simple, as you see right now. Look, guys, in the very beginning, X is here. In the very beginning, X is here. All what I'm going to do, I'm going to take whatever pointed by X, I'm going to send it to port P. Then I'm going to increment X. Okay, so now X is here. Then I'm going to take whatever there, I'm going to send it to port P. Okay, so in every iteration, I'm going to read two values. Okay, then I'm going to increment X for next iteration. So I'm going to repeat all the way until here. Once you come here, you have to bring it back to here. Okay, so as you see here, guys, this is the way I did it. X, I initialize X with the beginning address, as you see here. Then I'm going to take, as you see here, I'm going to take the value pointed by X. I'm going to send to port B. Then I'm going to increment X. Okay, so here, this one here, this one, guys, I'm going to take one of these values, okay, based on the iteration. And then I increment X so that I'm going to take one of these values, I send it to port B. Is that okay? Then increment X for next time. Then wait 1 second. That's it. Okay, I'm going to wait 1 or 5. That's the delay time I told you about. Okay, and now I'm going to compare X to the end. If X come to here, X plus 9. So if X equal the beginning plus 9. So if not, look. If not, so I'm going to come here. If not, I'm going to come here. Is that okay? So if you, so I'm going to come here. However, if you are at the end, I'm going to come here to reinitialize X. So once X comes to here, okay, so I have to return it back to here. So that, because it has to be continuous after you display 3, 4, 5, 7, I have to repeat again. Is that okay? I have to go back and repeat again. It's not only one time, right? And that's what I mentioned before comparing to LCD. In LCD, if you want to display a number, you just write this number one time, right? Because it has internally, it has a system that can do the work, right? However, here you have to keep. That's why you have to keep doing it. So you have to write 3, 4, 5, 7, 3, 4, 5, 7, 3, 4, 5, 7, 3, 5. So you have to keep doing it, right? This is different from LCD. That's what I want to say. Okay. Any question, guys? Very easy. Now I'm going to teach how can you do the same thing in C language. And again, that's very easy in C language. Look here. I'm going to use this easy function, segment 7 decimal, as I told you about. This function, you don't need to convert. Just give me the number, give me the display, and I'm going to enable this display. I'm going to write this number. That's it. Okay, as we see here. So, so this is the number I want to display. I'm going to put it in array. Okay, I'm going to call it this way. You have to enable LEDs. You have to disable 7 segment, as you see here. And then look here, guys. Number 1. Here I need to make four iteration, right? Because in iteration 1 I'm here, iteration 2, iteration 3, iteration 4, and then repeat again, right? So this part has to be repeated 4 times, okay? And then because this is infinite loop, I'm gonna repeat it again 4 times, and so on. In the 4 times, in the first time, I is equal to 0, I is equal to 1, I is equal to 2, I is equal to 3. Okay, and then after I'm done with this one, because this is infinite loop, I'm gonna repeat again 0, 1, 3, 0, 1, 2, 3, 0, 1, 2, 3. So I'm gonna keep doing it this way. Okay? When it is 0, in case of it is 0, that means I'm gonna put here 0, and then I'm gonna get number 0. So 3. I'm gonna get this one. I'm gonna put it here, and then the display 0. I'm gonna put it on display 0. Okay. When it is 1, this one is 1 and this one is 1. So that means I'm gonna take this one, I'm gonna put it here. Okay, I'm gonna display it on display number 1. Same thing if it is 2. So I'm gonna take this one, I'm gonna put it here, and then this one is 2. Right? If it is 3 and so on. Is that okay? And every iteration I'm gonna wait 5 milliseconds. So I'm gonna come here, I'm gonna display, wait for 5 milliseconds, repeat again. Very easy, right? Any questions? Okay, guys, any question? You understand the idea of multiplexing? Why? What multiplexing means? It means every 7 segment is gonna take some time slot. So this one is gonna take one iteration, but because I do it very fast, you are gonna feel like all of them are on at the same time. Is that okay? Any question? Yes. Yes, if you remove this one, if you remove this delay, what's gonna happen? You are gonna put 5 volt on the pins and then you remove it quickly, right? So you are gonna see 7 segment dim. Because for any LED, to reach to the maximum brightness, you have to keep the 5 voltage for some time. You got what I'm saying? Yeah. So you can try it by yourself. So try it, remove the delay and see what's gonna happen. Okay. You will see that they are dim. Okay. Any questions? Now, how I can do the same program but using RTI. Okay. Again, I'm gonna do exactly same thing, guys. I'm gonna do exactly same thing. The only difference is every iteration here is gonna be 1 interrupt. So in 1 interrupt, I'm gonna take these 2. In second interrupt, I'm gonna take these 2. Third interrupt, I'm gonna take these 2. Fourth interrupt, I'm gonna take these 2, and then I'm gonna go back, repeat again. You got what I'm saying? So every interrupt, I'm gonna take 2, right? This is one difference. The other difference is you cannot increment x. You cannot increment x as I did here. So that's why I'm going to use a variable. So I'm going to use count here. I'm going to use a variable. So count 0, 1, count 2, 3, 4, 5, 6, 7. Once it comes to 8, so that means count should be 0 again. You got it? Okay. So now I'm going to show you how can you do it. It's the same program, but I'm going to jump to chapter 4. I think this is the best way to teach this part. Okay, to show you the 2 programs. Okay, chapter 3 and 4. Yeah, look here. Yeah, I want to display this number 3, 4, 5, 6, 7 using RTI. Okay, so is exactly same thing as I have done right now. You have to create this table. You have to create this array. Okay, guys, this is number 1. Number 2, I'm gonna have count. That's what I told you, count. Okay, count should tell me in this interrupt which number I have to put on port B and P. As I told you, count 0, 1, 2, 3, 4, 5, 6, 7, and once it comes to 8, I'm gonna go back to 0 again. Okay. So again, here I initialize RTI. Okay. Here. Also, this is the main program. In the main program, you have to initialize the 7 segment LEDs and so on, as you see here. Also, here you have to initialize 7 RTI. However, listen to me. This is a very important thing. However, I'm quite sure at certain point some of you are gonna make this mistake. I'm sure. Okay. Usually we use 7F here. Okay, because 7F is used if you want to make 1 millisecond delay. If you remember, 7F is going to be 131 millisecond. Okay, so that's why this is a problem. When we usually use 7F, you are going to put here 7F. 7F is going to make 131 millisecond. It's just too much delay. That means every interrupt is going to be every 131. So you are going to change the number. You are going to change the number every 131 millisecond, which is too long time. Okay, so that's why you are going to see flicker. Okay, so if you see flicker, okay, you should know something wrong in your setting to the interrupts. The interrupt should be quick, right? Interrupt should be quicker. So here I select number 10. I tried it, it worked. You can select any number based on the table, as I explained before. I think this one gives you, I don't remember exactly, but I think 0.2 milliseconds, something like that. And I found it's okay to do it this way, okay? Anyway, you can try another number. Very important thing, okay? That means we're gonna have, because in every interrupt, as I told you guys, these two for one interrupt. Next interrupt, these two. Next interrupt, these two. Next interrupt, these two. So the time between each two interrupts, this is very important, this time. If this time is long, like 100 milli 1 second, you're going to see flicker, right? So anyway, so be careful about this one. Anyway, so now, and the main, as you see here, I'm not using the main program, so I'm going to keep looping here. Is that okay? The way it should work, guys, as I told you, in every interrupt, so interrupt here is like iteration in the main program, like iteration. In every interrupt, I'm going to take the value pointed by x plus count, and then x plus count plus 1, this value, okay? How? Same thing as explained right now, a comma x. So I'm going to put count in a. Yes. So let's see. Look here, guys. Again, you have to clear the flag bit. You have to end it with RTI. Okay, we don't talk about this. And then x, I initialize x with the beginning, and then I put a I put count in a. Then I'm gonna read the value pointed by a comma x here. So here actually the value pointed by x plus count, because I put count in a. And now I increment count. Then I'm gonna repeat again. So I'm gonna take the value pointed by x plus count after you increase count, and this one you put it in port P. Okay, guys. Again, if you are using the RGB, you have to be careful when you use this one. When you are using RGB, you have to be careful when you are using this one, right? Why? Because this move is gonna write to the RGB part. I recommend, here it's okay because I'm not using RGB. I recommend to use bit set and bit clear, okay? If you are using RGB, okay? So, and then after that, I increment count. Then I'm gonna see if count is equal to 8 or not, because I told you if count equal 8, so it means count is here, so I have to go back to the beginning again. Any question? So here, I'm gonna compare count to 8. If it is not okay, if it is 8, you have to go to 0 again. Okay? Because I have to go to the first number again. Any questions? It's exactly same program, exactly. It's the same idea, but I just used count. In the other one, I didn't use count. I just incremented x, but exactly same thing. And also, in the main program, iteration here means one interrupt. Iteration means, be careful here, because I see some students still don't understand what interrupt mean. Okay, be careful here. Where is the delay? You forget to make a delay here. You forget to make a delay. True or false? So if I go to chapter, still, if you ask these questions, that means you don't understand what interrupt means. Simple. Okay. So here, look here. Here, if I compare this program with this program, here I make a delay. In case of interrupts, I don't need to put a delay there. Why? Because the delay is gonna come from the interrupts. I don't need to write an instruction to make a delay. Okay? Because here the delay is gonna be done by RTI, right? So RTI is gonna interrupt one interrupt here, and then the next one is gonna be after some time. This is done by RTI. Here, you have to write an instruction to do it. You get what I'm saying? If you are confused here, so that means you don't understand what is the meaning of interrupts. Okay? Because this delay is gonna come from RTI. Okay, so RTI should count for this delay. Anyway. Great. What else I have here? Okay. Yeah, I have some interesting stuff here, but let me see in chapter. So I think, yeah, I finished what I want to teach in chapter 3. I want to teach more stuff here. Look here, guys. For example, this is what I taught right now. I'm here. How can you use 1/7 segment? How can you use 1/7 segment for counting? So you count 0, 1, 2, 3. That's what I explained. However, look here. So this is the counting 0, 1, 2, 3, 4 counting. However, I want to modify this program so counting is done by RTI, as you see here. So RTI is counting 0, 1, 2, 3, 4 until 9, and then 0 again, right? I taught this program. However, I want to modify this program so that I want to use a push button to turn the counting on or off. You know what I'm saying? So when I press a button, no counting. When I press it again, it counts. Is that okay? How can you do that? I think that's what we did in the last lab, okay? Same idea. So I have two solutions. I want to show two solutions, okay? I have two solutions. One solution is I can use IRQ. And inside IRQ, I can write something like that. I can say here, you flip, this is the enable bit, you flip the enable bit, and this part for debouncing. I can write it inside IRQ. Is that okay, guys? You understand what I'm saying? Okay, so this is one idea. Also, as I told you, we can do the same thing, but you can do it in different ways. So now I want to show you, I can do the same thing, but I'm not gonna put it in IRQ. I'm gonna put it in the main program. Don't tell me why. I just want to tell you we can do the same thing in different ways, okay? If you think it's better for you to do in the main program, that's okay. However, and this is the main thing to understand what's the meaning of interrupts. However, if you do it in IRQ, I don't need to check if you press or not. I don't need to check because this is checking is done by IRQ. You get what I'm saying? However, if I write in the main program, I have to check you pressed or not. That's what I'm going to show you right now. So if you see here, guys, I want to show you, here, it's going to be like counting, and there is one push button to turn on and off. Is that okay? So the way I did it, as you see here, I'm going to put it in the main program. Okay? So here, I'm going to check. I'm going to look at PH0. If PH0 is 1, it means you didn't press. 1, right? You didn't press. You remember every time you press, you make something like this one. So if it is 1, that means you didn't press. So I'm going to keep looping here. I'm going to check again. So I'm going to read port H. It is 1. Okay. Read port H. It's 1. So I'm going to keep looping here. Okay. So as long as you don't press, so I have to keep it checking. And that's what we call it pooling. Okay. So I have to keep it checking here. Once it is 0, I'm going to come here this way. Once it is 0. So once you press the button, it is 0. So I'm going to do, number 1, I'm going to flip the enable bit so that if counting is working, I'm going to disable counting. If it is disabled, I'm going to make it on. You understand what I'm saying? I'm going to choose a video, make it better. And then I have here debouncing code, and then I'm going to come back again. Okay, guys? So if you want to use, please, this is very serious, very important. If I want to use IRQ, guys, I'm gonna take this part, only this part here. I'm gonna put here inside IRQ. Is that okay? I don't need to check. I see students inside RTI, they put a delay. I see students inside IRQ, they check if it is 1 or not. You don't understand what the meaning of interrupt. Okay, guys? The meaning of interrupt, once I go inside the IRQ interrupt, it means you already pressed the button, right? You don't need to check. This is done by the hardware, right? But here, because I put it in the main program, I have to check. Okay, guys? So this is one way, and you can do it in another way. So I'm going to choose a video now. Look here, it is counting. When I press the button, I'm going to disable RTI. So RTI now is disabled, no counting. When I press the button, RTI is enabled. So it's counting, right? Also, you should understand, guys, you should understand what it means when you disable interrupt, what it means. It means this interrupt is doing something like counting. For example, in this case, if you disable interrupt, so this functionality is not going to work, right? No counting, because who's doing the counting is RTI. If you disable RTI, no counting, right? Any questions? Okay, so if you want to put, I think, let me see. Yeah, this is something else. I'm going to explain it now, but anyway, now I have another program. Okay. So the way, if you want to disable it inside IRQ, as I told you guys, this is the second idea I told you about. I can put this code inside IRQ, as you see here. So inside IRQ, I'm gonna do debouncing, and then I'm gonna flip the bit. Again, I'm not gonna check if you press the button or not, because I'm not gonna come here if you don't press the button. If you don't press the button, I'm not gonna come here. So you don't need to check again, right? And this is the beauty of interrupts. You don't need to waste time to check, right? Anyway, this is done by the hardware. Anyway, so now I'm going to explain a couple of programs. They are very interesting. So what I want to do here, guys, is, let me see if what I missed here. Yeah, explain this one. I explained this one. I explained, yeah, this one. Yeah, look here, guys. What I want to do here, guys, I want to count. I'm not going to use timer. So I already explained how can you do like timer, okay? 0, 1, 2, 3, 4, and so on, okay? But here, I'm explaining here, how can you count events? So what do you mean by event? I'm going to tell you what I mean by event. For example, I want to count, here I have IRQ, okay? Every time there is an event, there is a falling edge come here. So I want to count how many falling edge I got, because every falling edge is one event, okay? Give me example. I'm going to give you example. For example, guys, you have infrared. You have infrared this way. So you have infrared light. You have light. For example, I can put it at the door of shopping mall or like Walmart or whatever. So every time you break this line, and this one is connected to IRQ, you are going to generate a falling edge, for example. So by this way, I can count how many people entered the store. Or if I put this one in the street, for example, so every time you hit it, it's going to be one car, for example. So I can count how many cars. So whatever it is. Okay. By the way, our garage, our home, at least in my home, but I think it's the same idea used in all homes. In the garage homes, we have something like that, okay, like a security. So if someone like a children or a child under the door is not going to close. This is children, right? So they use something like that infrared under is a garage, okay? Because if there is something here, automatic is not going to close the door. Anyways, his idea is this. So now what I want to do here, guys, is there is event like I want to count how many number of people, how many number of cars, how many number of boxes, whatever. So every time I have one box or car or whatever, you are going to get a falling edge on IRQ. So all what I'm going to do now, I want to count how many interrupts I have. Is that okay? How many interrupts I have? So the way I'm going to do it, as you see here, and not only that, I want to count, and then I want to display this count on the 7th segment. Is that okay? Okay. So before, maybe we don't have much time, but also I want to tell you something interesting as well. So one way to measure a motor speed, as I'm going to explain in chapter 5, one way to measure a motor speed is you can have a disk. You can have a disk like this one. In this disk, I'm going to make 2 holes this way, and this disk is connected to the motor. So this disk should rotate, okay? And I'm going to put here, there is a special device this way, okay? So here, transmitter and the receiver, okay? So if you look at the signal here, you will see something like that. It's going to be something like that. So this is the hole and this is the hole. So when in this part here, there is no light, so I'm going to get 0. Once there is a hole, I'm going to get a pulse this way. Is that okay? So every complete one rotation, I'm gonna get something like that. Is that okay? Okay. So all what if I want to measure the motor speed, is that okay? All what I have to do is I wanna see how many pulses. So it should be something like that, guys. So this is one rotation, second rotation, and so on. All what I have to do, I want to count how many pulses we have in 1 second. And then this will be, we call it revolution per second, right? I think revolution per second. So that's all what you have to do, right? So you can use the same program here. This program, I can connect this one to IRQ. I can connect this signal to IRQ. In IRQ, I'm gonna count 1, 2, 3, 4, 5, 6, 7. I'm gonna count. However, I'm gonna enable IRQ only for 1 second because I want to count how many ones we have in 1 second. Or if you want to make it more accurate, you can enable IRQ for 2 seconds, okay, and then divide the number you are gonna get divided by 2, so that you can get how many revolution per second. You got what I'm saying? So the same. So anyway, next time I'm gonna explain this program. What this program is doing is, you have IRQ. This one should count how many interrupts, IRQ interrupts we have, and should display this number on the 7th segment. Is that okay? Okay. Thanks, guys.